behind us there is our Lancaster NX611, and we're in the process of restoring her to airworthy condition. We made a 10-year plan back in 2016 when we did a complete paint strip of the aircraft to form what work would be needed to restore her to airworthy condition. So year zero effectively was the paint strip and survey of the aircraft, and that was done to really decide what condition the airframe was in, to then work forwards to restore it to airworthy condition. Prior to that, we had ordered 5 airworthy engines from Morris Hammond, which was the first stage to progress the path to restore her to airworthy condition. In year one, we restored fin, rudder, and worked on the trailing edge of the aircraft. Year two was the opposite, fin and rudder, and trailing edge, and various undercarriage support beams and parts of the aircraft. And then we really started to working towards the actual airframe, the structure of the aircraft, and restoring it to airworthy. Year three were the wingtips, which are still ongoing at the moment, and then we're working towards the larger sections. The original plan in year four, which was struck down by COVID, was to restore the rear fuselage part of the aircraft. So that came off the aircraft. We had a jig made, which is this one here, made by Intellect Engineering in North Lincolnshire. So that came off the aircraft, all the measurements were done, all the work was done to produce the jig, and then the fuselage was put into the jig. And everything was measured up. The fuselage was put back on the aircraft, ready to run the following season. Because COVID struck, we didn't have the funds in the centre to actually do the work to the rear fuselage, so we had to go back on the aircraft for another year while we raised the funds to do the work. The fuselage you see here is actually Lancaster KB976. So when we had the rear fuselage removed from the aircraft to make the jig, we had a visit from South Yorkshire Air Museum at Lancaster regarding one of our vehicles. They saw the work we were doing and said, well, we've got a rear fuselage of a Lancaster, do you want to use that while you restore yours? We said, yes please, we'll come and have a look at it. We went to have a look at it. KB976 actually had a hanger collapse on it. It was being restored to airworthy condition when the hanger collapsed on it, broke its back, and the remnants of it were sold to Kermit Weeks in Florida, and then the broken bits were left here in the UK while he went out and sourced a Lincoln to buy the broken bits from to make a Lancaster. So this changed hands a few times, eventually ended up at the South Yorkshire Air Museum at Doncaster, and it was used for some filming for a programme called Night Flight, which was partially filmed here and partially in studios as well. So what happened to it, because it was very badly damaged by the hanger collapse, the film company just kind of restored it sufficient for their film work. So they wrapped it in a really thick sheet of aluminium to keep it stronger, maintain its structure, and then they kind of glued on, riveted on bits of structure on the inside to make it look right for the camera. So luckily for us, we'd already produced the jig, we'd already had it all drilled off to our fuselage, so we knew that if that piece of rear fuselage from Doncaster could be restored to taxiing, we've got everything here we needed to do it. So we went and inspected it. There was quite a lot of damage to some of the formers inside, a lot of the stringers as well, but really the basis was there to make a usable part of airframe for the Lancaster. So we agreed on a deal, we moved it here and we fitted it into the jig. From that we've broken it down quite a lot, and now we're starting to build it back up again. The biggest problem with this is the formers that were destroyed. So we've got formers missing from around here up until here. So we're looking at about 6 or 7 formers that need replacing. Because of the damage that there was to this piece of fuselage, the original formers are of no use as a pattern. So we've had to work from drawings, and we've also scanned NX611 on the inside with 3D scanning equipment to produce the CAD drawings for the formers themselves. So we're at the process at the moment where those CAD drawings have been finished. They've gone off to a company to have them cut out of wood to make the blank forms, and then we will use those to make the formers for the aircraft. Luckily the formers in the inside of the fuselage are in half, so they split at the top and the bottom. So you have half a former with an overlap. So that makes producing them an awful lot easier. So when we receive the wooden forms from the company, we will then hopefully produce the formers here, and we can start fitting them to the rear fuselage here. When this is done later this year, we will then be able to fit this to NX611, take hours off, put it in the same jig, restore hours and then swap them back. That means that we can keep taxing the aircraft to raise the funds to restore it to airworthy. The biggest problem we have with this project is she has to be serviceable during the summer to raise the money to spend on her during the winter. So we've kind of changed the way we've approached this project as we've gone through it because of how long individual parts take to restore. So the wingtips have been a case in point, but I'll talk about those when we get back from over there and talk about the problems we've had with those. So we've kind of taken a precautionary step to work on other parts of fuselage to swap out with ours so that we have longer to work on ours in case we come across issues. So hopefully early next year, this will be ready to fit with the aircraft, swap them over and restore ours. Once we've finished with the jig for our rear fuselage, it will then be adapted for the next piece of fuselage, which is the one further forward of that. So this fuselage finishes kind of where the H2S scanner is on the aircraft, the blister underneath. The next piece of fuselage runs from there up to the trailing edge of the aircraft, the rear spar section. It's slightly longer than this piece of fuselage, so the jig will have to be slightly altered to receive it. The way that the aircraft works is it splits into transport sections, and this is what they call a transport joint. So there's large extrusion at these joints in the aircraft, so you can split the fuselage apart in sections. That meant that they could be produced at different areas in the country, brought together and bolted together and then flown off. But it also makes it ideal for us to take a sectional view of the aircraft and restore sections at a time. So with this being a sectional part of the aircraft, this face is the same as the rear face of the next section, so that we can just mirror this item and it can form the rear face of the next piece of fuselage and so on as we go forwards. So we've designed the jig to enable us to use it for many pieces of aircraft, many pieces of fuselage of the aircraft to make the most of the money we've spent on these items. So this jig will do the next piece of fuselage. It should also do the cockpit section of the aircraft, and we're looking at how we can also use it for other parts of the aircraft as well. So this is the rear fuselage ongoing. Again, ours will come out off the aircraft into this jig, swap over and then swap back again. We've looked at how can we use that process for other parts of the Lancaster as well. The hardest part of the aircraft to do is the wings, because of the very nature of them, the spark booms that run through them, and quite complex engineering within them. So really that was an ideal candidate for looking the same process for other parts. So if you look over to your right hand side, you'll see here we have an outer wing of a Lancaster. This is the outer wing of NX664 or WU21. We travelled over to Paris March of 2020, just before the country locked down, to speak to our French friends over there and work out a way that we can actually work together to help restore their Lancaster and restore our Lancaster as well. So WU21 is at the Bourget near Paris. It was actually rescued off Wallis Island. It's a Mark 7 Lancaster, just like NX611. And it was used for maritime coastal work just like NX611 by the French Naval Air Force. It had a taxiing accident on Wallis Island, and rather than recovering it back, they just looked at it and left it and carried on with their work with other aircraft. So it stood on Wallis Island for many years, and that's an island in the Pacific, so it's very remote from anywhere. And then many years later, this group in France and a museum in France looked at it and said, can we recover the Lancaster and bring it here and restore it, which they did. It took many barges and ships and movements and trailers to actually take the aircraft apart and bring it all the way over to France. While they were doing that, sadly it did suffer quite a lot of damage through the transport and moving it from ship to ship and the way they'd stropped it down on the loads, bringing it here and there. So we managed to strike a deal with the French company or organisation there who were looking after the aircraft and working on it. We've come to the arrangement where we can use their wings to restore them to a taxiing condition, swap them with the wings on NX611, restore ours to airworthy, swap them back. The main benefit to us is that we get the chance to make a jig without using our wings. We get the chance to learn all the problems, make all the errors, if you want to put it that way, doing this wing before we actually work on our own. So the jig over here is just coming together now. There's a few more bits just to add to it. before we can really start ripping the wing apart. So this is the port wing of WU21. It was the better of the two because during the taxiing accident the undercarriage collapsed on the WU21, the wing dropped, and where the outboard engine fits onto the wing, that struck the ground and has slightly distorted the spars in the wing. So using the port wing first, we can create a jig that is absolutely true, straight and absolutely to the original wing. We can trial it, our wing compared to the French wing, so that when we come to do the starboard wing of the French Lancaster, we know exactly where it should be, rather than making a jig from a bent section. So this wing at the moment is just waiting for the attachment points at the spar ends and the final top attachment points to be bolted down to the top or front spar, top spar as you see it here, before we can start stripping it apart. The biggest problem with British-built Lancasters from wartime is the types of rivet they used. They're magnesium alloy rivets. So over time the magnesium is affected by the air and it blows and it just makes the rivet disintegrate basically, it just powders away. So this wing's going to have to come apart, all the skins come off it, all the stringers come off, all be cleaned up, riveted back together again, skins put back on that can be used, reskinned where it can't, and then we will put all the wiring in, all the plumbing in, all the engine attachment parts, and then we will swap it out with our wing. So possibly next winter, or at least that's the plan, you will see the port wing of NX611 being hoisted off, this one fitted on, all the services and systems reallocated from wing to wing, and then our port wing will come into this jig here. And then walk over towards the jig. So this jig here can be used for both port and starboard wing. So you'll see as you look at the design of it, these vertical stands here can bolt on the corresponding side for the starboard wing. And you'll see as you look at the wing, it tips over, it's canted over. And that's because of the angle of the rear spar and the rear spar web and where the trailing edge bolts on. The trailing edge is just there. So it obviously cants over at the opposite angle depending on which wing you're working on. The top sections here bolt to the front spar, so the front spar runs here, the rear spar runs here, wingtip bolts on here. You see all the attachment bolts for the wingtip. So there's an extrusion on the wingtip, like a right angle extrusion which is all bolted on through here, the wingtip hangs out. Trailing edge here is the same principle, so all these studs here attached to the bottom of the trailing edge that you can see there. And all the open section at the bottom of that trailing edge is full of enclosure panels which are all riveted on or now screwed on with a modification to NX611. So that panel's removed, all of the nuts are undone, and then the trailing edge comes off the main wing section. If you look up the wing, this is a fuel tank bay. This is a number 2 fuel tank bay. Sorry, number 3 fuel tank bay. This one's number 2 fuel tank bay. And then this section here is effectively just outboard of the inboard engine, and that's where the wing, the outer wing, bolts onto the centre section of the aircraft. So if you can look back at the Lancaster from here, you see the tail fin sticking up. Forward of that is effectively where the joint is between the outboard wing and the centre section of the aircraft. So when you take this off, you leave the inboard engines on, and then just beside those is where the attachment points are.